Hello student, in this video I am going to discuss about time series analysis, and this video will continue up to 2 or 3 videos or 4 videos. This will be almost last topic of our syllabus, and also I'll try to cover up another few more topics if time permits. uh, some new examples related to business analytics. So here we start with time series analysis. Whether we wish to predict the trend, as we have discussed in the previous videos, in case of regression analysis or in case of forecasting method, also we have discussed about this, that whether whenever we try to make some trending or predict the trend in financial markets or electricity consumption or anywhere, time is an important factor that must be considered in our models. A time series is simply a series of data points ordered in time. In a time series, time is often the independent variable, and the goal is usually to make a forecast for the future. So main point is that we need to analyze the time. Time is the most important variable and independent variable, and goal is usually to make a forecast for the future. Here you can see a stochastic process. Here you can see YT is a stochastic process, and it's might be limited initial at any time. Starting point might be any time, but it will go from for infinity, and it will be equal to minus infinity. Uh, so it's a collection of random variables or a process that develops in time according to probabilistic laws. So it's a collection of random variables or processes or process that develops in time. The theory of stochastic process gives us a formal way to look at time series variable. So here you can see YWT stochastic process. W belongs to sample space and T is the index set, means that is time. So this is time set, and W is the belongs to sample space. So for a fixed T, the YWT is a random sample. For a given W, YT is called a sample function or a realization as a function of T. So two different perspectives. If the time is fixed, then W is random. If given W, if the W is given, then we can call a sample function. So Y will become a function or a realization as a function of T. Time series is a realization or a sample function from a certain stochastic process. A time series is a set of observations generated sequentially in time. Therefore, they are dependent to each other. This means that we do not have a random sample. Time series is a set of observations generated sequentially in time. Therefore, they are dependent to each other. This means that we do not have a random sample. We assume that observations are equally spaced in time, so the observations will be equally spaced in time. We also assume that closer observations might have stronger dependency. So we assume that two closer, any two consequent event or two or three or any closer event or observations might have stronger dependency. So suppose there are some examples here you can see. Let us understand this with an example. Let's say India expanded its military strength of 1.5 active military personnel in 2018 to 2 million in 2019. That is of course an increase in power. Sure, increase in military strength is not all to determine power, but let's suppose it is, because increasing in number might not be saying that we are increasing the power, but it might be giving some hint. So let's suppose it is. We know that in just 1 year India strengthened its military with 500,000 soldiers. So and again a closer look shows how much Indian military has strengthened in a year. Clearly we can see something is dependent on time, and say we have reasonable records proving the change in the number over different points of time, and then we call it data set, and we can use it to predict the number for future. Now this is time series analysis, because we are predicting the number for the future. That is time series analysis. We cannot predict the result of a war with the number of soldiers, but we sure can predict the number of soldiers with the data, and that is the power of data. Here you can see one definition: discrete time series in one in which the set T0 at which observations are made in a discrete set. Continuous time series are obtained when observations are recorded continuously over some time interval. So the two difference between discrete time series and continuous time series is that in discrete time series there will be a set of time or t naught at which, so for those specific time slots only some observation will be made in a discrete set. But in case of continuous time series we will try to gather continuous value of or records or observations over a specific time interval only, not any specific time count or time unit, but in a specific time interval. So there are various examples like data in business, economics, engineering, environment, medicine, art sciences, and other areas of scientific investigations are often collected in the form of time series. Also, like if you want to read the hourly temperature readings, or if you go for daily stock prices, and also if you see weekly traffic volume, annual growth rate, seasonal ice cream consumptions, electrical signals, lots of other also examples available as a time series. So we can analyze those time series and predict the future data. There is a company X which has been keeping a record of monthly sales of shampoo for the past 3 years. Company X wants to forecast sale of the shampoo for next 4 months so that the demand and supply gap can be managed by the organizations. So our main job here is to simply predict the sales of the shampoo for the next 4 months. So there is a company X which has been keeping a record of monthly sales of shampoo for the past 3 years. So that is a time series or time limit, and forecast the sale of shampoo for next 4 months so that demand and supply gap can be managed by the organization. So we help with the help of analysis of the data getting from 3 years using some time series analysis, we can predict the or we can forecast the data for next 4 months. So our main job here is to simply predict the sales of the shampoo for the next 4 months. So dataset comprises of only two columns. One is date of the month, and another is sale of the shampoo in that month. So there is a company X which has been keeping this. This is the data. Sales is this, and this is the date column. This is a sales column. So again there are other examples like this is another example, the US employment rate since 1990. Here you can see time value is the year, and this is seasonally adjusted unemployment rate. So we can see from the 1990 how that unemployment rate has been increased. Okay, again here one thing is you can see is that average monthly temperature in Iowa. So temperature function is our Fahrenheit value is here, and again we can see between 1964-66 how the temperature is changing at different times, average monthly temperature. Again one other example is the US producer price index in 12 month change finished goods. So this is increasing or decreasing point. This is negatively decreasing, and it is positively increasing percentage, and that is in case of January 95, January 96, that is the time sets. So you can see these are the discrete values. Again another one is here example, pounds of milk, the weight of the milk, and you can see milk milk. This is the blue line is for milk from the cow, and this is genetic gain, means how that uh, population get gain from that milk. And also average class 3 milk price also important here, means how these three are related with that timeline, or you can say time series analysis. Here you can see the green line, that is average class 3 milk price, how it is increasing or decreasing. Class 3 milk price increasing per dollar per C weight. It's in a unit of weight or cubic weight, that is. So we can see somewhere around 1983 1980 it has been increased steeply from the previous one, but in that way the trend is almost same, increasing manner, but this was high increasing or steep increasing. Again here another one is that detrended Nile River record. So detrended is the red one, original is the blue one. So this is the timeline, time year 700 800 year, and this is the value of the detrended unit or original unit, means it might be the distance. Daily portfolio closings. So these are daily portfolio logarithmic returns. So this is closing level of, might be stock exchange or might be anything, but this is a closing level, and this whole thing will be in logarithmic scales. Daily portfolio logarithmic returns. So this return value is created using the logarithmic value. Again another one is components of US GDP percentage change compared to 1929 constant prices. So how that GDP has been affected from 1929. This is GNP for black, green for personal consumption, the pink one is government consumption, and red line is gross private fixed capital information or capital formation. Again one example, here you can see example of some time series. Here quarterly US beer production for this one, daily average number of truck manufacturing defects, yearly US tobacco production, contaminated blow fly data. So these are different types of time series. So we can see different type of analysis, or we can different type of pattern in each one. Also here this is Lindia Pinkham advertising and sales data. So this is advertising and this is sales data. You can see the similarity between these two or correlation between these two data. Okay, and again this is international airline passenger totals, and again monthly readings of ozone at downtown LA. So two different things, and but there is a negative correlation between these two data. Again one, this is example of sunspot numbers. The Wolf number, also known as the international sunspot number, relative sunspot number or Zurich number, is a quantity that measures the number of sunspots and groups of sunspots present on the surface of the sun. The sunspot number is a crucial tool used to study the solar dynamo, space weather and climate change. So we can see in various fields, in various topics, the time series analysis has been done, and it is important in fact of analysis or in fact of for the prediction of data in view of the future. So these are some examples. You can go through many more. So in the next video I'll try to go for more of this time series analysis. So if you find anything to add or anything to discuss or anything, if you have any confusion, please let me know. I'll try to resolve those things over Google Meet. Thank you.